Hey guys, welcome back. Dr. Ryan Lawrey here, and today I want to talk about a topic that has a lot of confusion in the keto community, and I know there are many questions, and I want to address each one of them. And that is about a very important topic, and one that's getting talked a lot about, and that is the truth about exogenous ketones, the science behind them, and what applications might they have, what are they, and what they are not. And so if you've listened to anything I've spoken about before, or been on my channel before, you've heard me speak about a ketogenic diet, but you might not know what are exogenous ketones. Well, first and foremost, it's important to understand there are three ketone bodies. That is acetone, which you breathe out, acetoacetate, which you excrete out in your urine, and there's beta hydroxybutyrate, or BHB, which you typically test in your blood, and that's the primary ketone body. So now that we know that, we need to understand and jump right into this of understanding that ketones being looked at as a superfuel or being looked at even via supplementation is not a new concept. In fact, the first study that was really ever done was in 1945. And this study by Lawrey and Phillips looked at BHB improving oxygen efficiency and sperm motility in animals. So literally, the first study that was done was looking at these bulls and found that BHB, that main ketone body, which we'll be talking about throughout this entire lecture, is improving oxygen efficiency and sperm motility. Now, the first thing to really address, because I know there's a lot of confusion out there, is the difference between ketone salts and ketone esters, right? Ketone esters have had a lot of animal research on them. They've been around for a long time, and Dr. Richard Veach was one of the pioneers who really spearheaded a lot of this exogenous ketone ester research. We know that they can significantly elevate ketones. It's been shown and documented over and over again. Some of the trouble with ketone esters are the taste. It tastes like jet fuel. It's a brutal taste due to the way it's made, and it's a liquid form versus ketone salts being more of a powdered form. They're expensive. It's difficult to make, and per serving, it could be upwards of $30 or $50 per serving. Many years ago, it was like hundreds or thousands of dollars per serving. And there's little potential for mass market. There's a potential for a clinical market, but very little potential for mass market with esters. Ketone salts are new and emerging and continuing to rise, right? There's cost-effective dosing if you're utilizing the right form, which we'll be talking about. They taste delicious, some of them, and they're on the market now, and they're easy to travel with. Some of the cons are that there's a big salt load that some are worried about because BHB is bound to mineral salts, sodium, calcium, and magnesium, which people shouldn't be worried about under normal conditions, and we'll discuss that at a different time. One company, Prove It, uses a natural R isomer in the keto nat. A lot of companies, and this is one of the cons, is that a lot of companies are selling low quality, ineffective material. And we'll touch on that at the end. Well, I mentioned the R isomer, so it's important before we jump into some of the science behind exogenous ketones. What are the differences? What are different isomers? What does that even mean? Well, an isomer is a compound that has the same type and number of atoms as another compound, but are arranged in a different sequence. I use this example all the time. Take your hands and stick them in front of your face, right? Stick them in front of your face, and you look, and they're almost mirror images of one another, right? Well, they're not the same. If you overlay them on top of one another, they don't match up, but they're mirror images of one another. And that's really what the different isomers do. And so you'll hear terminology when you're listening to podcasts or videos and people talking about exogenous ketones such as racemic. Well, racemic means it's composed of both the D isomer and the L isomer in about equal proportions. So it's like the equivalent of having a left and a right hand inside of a formula. Non-racemic means that it's not equal proportions of D and L. And in most cases, it's the actual D form versus a combination of the D and L form. So I hope that clears up what isomers are and what's effective or not. Well, if we want to look deeper at the effectiveness of isomers and isoforms, we look no further than drug development or even branched chain amino acids that we supplement with daily. So a good example is L-DOPA. I was just doing a lecture recently for our students in Keto Mastery looking at L-DOPA, which is commonly used for Parkinson's disease. And there's a different one called D-DOPA, which never gets utilized. Why? Because it causes deficiencies in white blood cells and increases susceptibility to other infections. So with DOPA, the L form is the actual effective form that they utilize in Parkinson's. No one ever supplements with the D form because of it has complications. Another example is R-naproxen. We know that from Aleve, which is commonly utilized. It's used for pain, while S-naproxen, or the counterpart to R-naproxen, is a teratogenic because it's been shown to have pregnancy issues and issues with fetal development. So that's why you look at things like Aleve use the R form, not the S form. You'll hear me talk a lot about D and L or R and S. It's the same thing, it's just different nomenclature. R and D are the same, L and S are the same. So R-naproxen seems to be the effective form for Aleve. When you're taking amino acids, what do you utilize? You see this commonly on labels and supplements. L-leucine, right? You never hear of D-leucine or people supplementing with that. No, because L-leucine is the effective amino acid or the effective form of the amino acid that actually gets taken up and utilized by the body. And so it comes down to utilizing the right key, right? If you think about it like a key in a doorknob or a key in a door, right? Many keys on your key ring might fit in that lock, but only one key opens it up. And with exogenous ketones, that form that is actually the form that our body naturally makes and our cells can recognize is the R and D form. And we'll discuss that a little bit more, but the R and D form is the actual bioavailable form, whereas the S or L form is not. And that's shown here. Our bodies naturally produce, this is a study from 1982 showing that almost 100%, nearly 99% of what our bodies produce is DBHB. There may be a little bit of LBHB, maybe a little bit of LBHB, but our liver naturally on a ketogenic diet produces DBHB. And studies show that LBHB, if anything, gets converted over to DBHB, right? So it's not like it's having some unique property on its own, it's getting converted over. The isomers are used differently, and studies here show that the L isomer is actually favored for lipid synthesis, which we would not want, which is fat synthesis, and less favored for respiration, while the D isomer is favored for respiration and less favored for lipid synthesis, meaning that they get metabolized very differently, right? And again, like I said, LBHB likely just gets converted over to DBHB. If it's not being used as substrate for lipid synthesis, it's just getting converted over to the actual bioavailable form. So now that we understand the difference between salts and esters, we understand the difference between isomers, what's the actual effective isomer versus a non-effective isomer. The question that everyone's asking is, what do exogenous ketones do? Well, one, we know that ketones are a more efficient fuel than glucose. ATP is our body's energy currency, right? The more ATP our cells make, the more energy we have to function throughout our day. And per unit of oxygen, ketone-derived ATP derives more energy than glucose-derived ATP, meaning that running on ketones is more efficient or better for your energy levels, right? And I'll use the example so you know what I mean by efficiency, is imagine you're a runner, a long-distance runner. If you're efficient, when you're hitting the ground with your feet aren't staying on the ground very long. You kind of hit and come up. If you look at a really good runner, it's almost as if they're gliding when they're running. You look at someone who's very inefficient, like myself, who doesn't run very often and was a poor runner, they're like, doom, doom, doom. You hear them stomping. That's very inefficient. You're wasting a lot of energy, and you're not being as efficient as a runner who looks like they're gliding. The same thing goes with ketones versus glucose. So that's something to keep in mind. That's number one. Number two, ketones increase satiety and fullness. And this is a study that was recently published by Dr. Angela Poff, actually, in her group, exploring the viability of exogenous ketones as weight loss supplements. And they were looking at this in animals, and the question is why? Why were they looking at this in animals? Well, you look at this study by Brianna Stubbs, and they looked at a ketone ester drink lowers human ghrelin and appetite. And we know that being in a state of ketosis and the ketogenic diet by nature blunts appetite. There's review and meta-analyses on these that they're affecting certain hormones in our bodies that are blunting our appetite. Ketones, exogenous ketones, have been shown to not only decrease hunger, decrease our desire to eat, but also increase our fullness. So there's huge potential there if done right and if done with the effective dose that we'll talk about later, that ketones may directly suppress appetite and lower ghrelin levels, perceived hunger, and desire to eat. Now, why is this important? In general, if you just think about most people who diet, there are studies looking at this, looking at long duration dieting. Well, when you look at long duration dieting, we gain more than a third of the weight back in a year and most of the weight back that we lose during a diet in 3 to 5 years. If you look at the recent study that was published on The Biggest Loser, most of them have suppressed appetites, and so they're starving after they're on that show and they regain a lot of that weight back. Even not on that show, we're seeing the same thing in studies. If we can help mitigate our appetite and take appetite back and put it in our control, that would be a huge thing. And we've seen this with studies on the ketogenic diet, where 6 months of ketogenic dieting was maintained up to 44 months, likely due to mitigating that because being in a state of ketosis helps suppress appetite. So people, despite them dieting down, aren't as hungry. So I guess the second benefit that I would talk on with exogenous ketones is that they help suppress appetite, help decrease hunger, help increase fullness, which is very, very important. 3, this is a study by our group, and we teamed up with our colleagues at Auburn University, looking at something known as caloric efficiency. And ketones may make you less efficient at storing calories. Now, what does that mean? Caloric efficiency is the amount of weight you gain over the amount of calories you consume. We know that the calories in, calories out thing, there's a lot more to it. So there are people who are more efficient at gaining weight and people who are a lot less efficient at gaining weight. Perfect example is we all know someone who looks at a cake, puts on 5 pounds, right? That's an exaggerated example, but that person is more efficient at storing calories. We also know the other person who could eat donuts and eat whatever, and they're shredded, and they're less efficient at storing calories. And so we did a study where we looked at a carbohydrate-based diet, carbohydrates plus exogenous ketones, a ketogenic diet, and a ketogenic diet plus exogenous ketones. And in a linear fashion, we saw a decrease in caloric efficiency, meaning they were less efficient at storing calories, which is a good thing, from carbohydrate to carbohydrate plus ketones to a ketogenic diet to a ketogenic diet plus ketones. So ketones may make you less efficient at storing calories. One of the ways that may be the case is through this next mechanism. Ketones have been shown to increase brown fat. So we know mitochondrial biogenesis, or the formation of new mitochondria, is very important. And so this study gave a ketone ester diet for 1 month, increased the amount of mitochondria, doubled proteins that were associated with brown adipose tissue. So that may be the mechanism why. Another benefit of exogenous ketones. Ketones may increase mitochondrial function and improve mitochondria number. So we know as we get older that mitochondria go down in almost a very rapid decline after the age of 30. Our mitochondria function number go down, and by the time we're in our 60s, they're really low. Now, there are some ways to mitigate this. Mitochondrial dysfunction is at the core of a lot of issues that we have going on in our society. This study by Vicha's group showed mitochondrial biogenesis and increases in uncoupling protein with animals fed a ketone ester. So we're looking at things like cytochrome C, uncoupling proteins, all were increased with animals given exogenous ketones. This is a more recent study by Parker et al. In 2018. BHB increased mitochondrial changes in skeletal muscle. Again, showing and confirming that ketones may improve and have been shown to increase mitochondrial function and number, which is very important. Another benefit is that ketones actually make us more insulin sensitive, which is very important. So you look at this original study back in the 50s, and they looked at changes in blood glucose metabolism when they infused BHB, and infusion of sodium BHB lowered blood glucose. On top of that, since then, we've seen studies in the 90s looking at ketone infusion improved insulin sensitivity by about 40%, decreased cortisol levels, and on top of that, suppressing food intake, which we've already discussed. A more recent study was looking at prior ingestion of an exogenous ketone ester mitigated or attenuated the glycemic response to an oral glucose tolerance test in young healthy individuals. What they did was they gave the ketone ester before a meal and before this oral glucose tolerance challenge, and they found that the ketone ester helped improve insulin sensitivity by about 11%. So exogenous ketones may be helping improve insulin sensitivity, which is very important. Dr. Veach and some of his colleagues did some work looking at ketones and heart function. There are studies looking at infusing the heart with ketones versus carbohydrate, and found that the heart that was infused with ketones had 28% greater efficiency in heart pumping action. And all those studies are cited here. And at the end of this, I will point to to a place where you can find all of these studies and more studies around this. Now, do ketones improve performance? So here's a recent study by our friend Dr. Malia Holland, where they took firefighters and they looked at a supplement containing RBHB for 7 days, just for a week, versus a placebo. And they basically put them on a treadmill at 60% of their VO2 max. They saw that ketones went up to about 0.6 after 30 minutes of ingestion. And on average, from the placebo to the ketone group, average heart rate during that work went down, which is important, right? Think about people who are going into our firefighters or people. You want to be able to help mitigate some of that increase in heart rate. They didn't look at direct performance, but this is an indirect indice that it may actually be helping heart rate, potentially through that mechanism that I talked about earlier with improving efficiency in the heart. Here's a study looking at nutritional ketosis altering fuel preference and performance and endurance athletes. And they found that the ketone group versus the carbohydrate group, blood lactate levels, we know that blood lactate builds up when we're exercising, was cut in half. In the ketone condition, even just versus the fat condition or the carbohydrate condition. Lactate, why is this important? And I won't dive too deep into the details because I could go on and on about some of these mechanisms, but I'll save that for something I'll touch on later. Ketones and lactate use the same transporters. So potentially by supplementing with exogenous ketones, you're increasing transport capacity, which will help clear lactate. If you're building the tunnels or you're building these mechanisms to clear ketones and become better ketone users, you're potentially using those same tunnels to be better lactate users as well, which is important for endurance performance. Here's a recent study by Dr. Jeff Volek's group out of the Ohio State University looking at an RBHB formula. They actually looked at the Pruvit's finished formula on cycling performance. And they did an endurance capacity test. And I won't go into the details. You can look at this study. But they basically found that 10 out of 12 people cycled further, about an 8% average increase in these individuals looking at their cycling performance. And there are studies with ketone esters looking at cycling performance and seeing improvements. So it seems to be that exogenous ketones can help increase. Right now, there's a focus on cycling and performance, but also hopefully new studies are being done currently on other areas outside of cycling performance. The other thing is that ketones spared the breakdown of BCAAs in this cycling trial. So you look at leucine and important amino acids. In the ketone group, they weren't oxidized as much. When you're giving an exogenous ketone ester, it's preventing or blunting the breakdown of a very important amino acid, which is leucine. And that's the other benefit I want to talk on with exogenous ketones, is that ketones may have both an anabolic and an anti-catabolic effect. And what I mean by that is the anti-catabolic effect from what I just talked about with preventing leucine being broken down. And there's another study showing that when you give BHB, you prevent the oxidation of leucine and potentially promote protein synthesis or the building of new muscle in human beings. And we've worked on a study, again, with Wes and the group out of Auburn University showing that from a standard chow to a ketogenic diet, and then when you took a standard chow and supplemented a moderate amount of ketones versus a standard chow and a high amount of ketones, you see an increase in muscle protein synthesis even with a standard chow just supplemented with exogenous ketones. Not even a ketogenic diet plus exogenous ketones, just a standard chow with exogenous ketones on top. So they may be anabolic and anti-catabolic. Another potential benefit is that ketones may increase blood flow. Cerebral blood flow in this study was increased by 30%. And so I'll link these studies for you guys to check out. But again, blood flow to the brain, which we know is impaired after any trauma to the brain, but also as we get older, seem to be improved between the control and ketone condition. Ketones may lower inflammation. And here's plenty of studies looking at BHB suppressing the activation of something known as the NLRP3 inflammasome. And then this has been shown over and over again. BHB, the main ketone body that we're talking about, is attenuating a lot of this inflammation, primarily, which we think is through blunting this main target, which is the NLRP3 inflammasome. There are several studies that kind of confirm this. Here's a recent case study that we actually published looking at the effects of exogenous ketones on biomarkers of Crohn's disease. And this was a case study looking, and the main takeaway was looking at something known as CRP, C-reactive protein. And so the average range is anywhere from a little over 0 to 5. This individual's C-reactive protein was over 60. It was about 63, which is crazy. You see this a lot in autoimmune diseases, high amounts of inflammation, and you can measure that with C-reactive protein. 3 months after implementing just walking daily and exogenous ketones, significantly decreased CRP levels to normal levels. So again, they may be able to lower inflammation. Another potential benefit, and this is from my friend Elena Gross, she's looking at the potential mechanism of ketone bodies in migraine prevention. And I'll show you all the different mechanisms by which she's alluding that BHB supplemental ketosis may be decreasing reactive oxygen species, may be having an effect on ATP, may be having effects on mitochondrial function, the microbiome, the digestive system, all which help mitigate some of the symptoms of migraines. She did a safety study looking at the effect of literally supplementing with exogenous ketones, and now she's into full-scale trials, and one of her case studies that she recently presented at a metabolic health summit was this proof of concept, not only looking at ketones over 2 months, but she compared 10 grams of DL-BHB, the mixed isomer, versus 10 grams of DBHB on symptoms or conditions of migraines, and she looked at the amount of days with migraines. Without BHB, you saw about 10 days in this proof of concept. With the mixture of the D and L isoform with BHB, it went down to 8, so some improvement. With the D form, you're down to 3.5. So again, a lot of it depends on the actual form that you're utilizing, but based on her research, there seems to have a lot of promise for migraines. Ketones have therapeutic potential for the aging and dysfunctional brain. We know as we get older that our brains are unable to utilize glucose as well. And this tends to start at around 30 years old and tends to go down. Our ability to utilize glucose in our brain significantly gets impaired. What happens if we provide the source through a ketogenic diet? We know, but what happens through exogenous supplementation? Well, one of the first studies was done in 2004, looking at a small elevation in ketones through MCT supplementation. And the bump only went up about 0.5 to 0.6 millimoles, which would likely be a lot higher with exogenous ketones, but they basically found a direct relationship between paragraph recall and serum BHB levels. So the greater the ketone levels in the blood, the greater the recall changes, or the better their brain or memory was working. And again, Dr. Stephen Cunnane, a good friend of ours, is seeing the same thing in individuals with Alzheimer's disease or healthy individuals. The plasma level of ketones is directly correlated between the amount that's getting taken up into the brain, right? So something that is just interesting to be aware of. Additionally, ketones may increase BDNF, brain-derived nootropic factor. And here's 2 studies looking at exercise. We know increase BDNF, and it's primarily through the ketone body, BHB. And we know when we give BHB within a physiological range that it could promote BDNF expression in neurons and serve as a novel signaling factor, which we'll mention here shortly. So again, ketones may have benefits for this neuroprotective aspect, which is known as brain-derived neurotropic factor.